All right, ladies and gentlemen, welcome to our discussion about regular polygons. All right, let's try and remember. Regular polygons means we are talking about shapes that are not only equilateral, but they are also equiangular. That means all of the sides in our shape will be the same measure, and all of the angles, all the interior angles will be the same measure as well. Now, the cool part about this is there is one formula. And notice polygon just means many sides. So as long as we have three sides, we're really talking about a polygon. So we have this cool, we have a cool formula or equation that will help us find the area. It doesn't matter if we have 3 sides or 300 sides, as long as the object is a regular polygon. We can find the area by doing this idea. We're going to do 1/2 times A times P, okay? Now that lowercase a does not refer to area, so that lowercase a is a new type of idea. So if we're going to look at this, let's go ahead. Maybe we'll do, let's just take a look at one object here. I'm just going to go ahead and draw us as best as my artwork can do. That's not bad. That's a half decent 6-sided shape. Just we have to understand that we're looking at something that's regular. So not only are all of these sides the same measure, but all of these angles in here are the same measure as well. Okay. Well, this formula is going to help us find the area of this polygon. Now, one of the letters you might be able to guess, P, stands for perimeter. So I'd want you to know that if I know the measure of any of the sides of this object, I can find perimeter because they're all the same. I can add them up. I already know the perimeter is 60. Now, A is a new idea. All right. A is this crazy word called an apothem. I got to try and say, what the heck is an apothem? All right. More than likely, that's a very new word for you. Well, let's take a look at what an apothem is. An apothem, well, let's first off talk about some stuff that we might already know. If I put a point here in the middle of the object, hopefully you realize that point is referred to as the center. Okay? If I were to draw a line from the center out to any of these vertices, that's actually referred to as a radius, because I could draw a circle that goes around this object that would hit all of those vertices and inscribe this entire object. So you want to think, all right, well, how many radii could be in a hexagon? Well, I could draw one over here and here. I could draw one to all of the points. That means there's 6 different radii in here. What an apothem is the distance from the center, all right? And I want you to understand, if I go to the center of one of the sides, that is not a radius. Hopefully you realize it's got to be shorter than a radius. So if I go to the center, it's going to make a perpendicular intersection. That's got to be shorter because I could draw another radius here to that vertex. That makes a right triangle. Well, if it's a right triangle, then this radius is the hypotenuse, which makes it longer than this dotted line. All right, so these are all radii, and this is an apothem. Now, how many apothems could I draw? Well, there's 6 sides that I could all draw a line all to the center and cut that side in half. So I have 6 different apothems. So this right triangle that exists here can be replicated 2 times. Does everybody see 1 here? 2 every time we have a side. So there'd be 2 more for this side, 2 more for this side. That means inside of a hexagon, there will be 12 exact copies of those right triangles. So technically what we could do if we wanted, we could find the area of one of them and then multiply by 12 if we wanted. Well, guess what? This is just a kind of a shortened version. This looks a lot like the area of a triangle formula, 1/2 times base times height. Okay, well, just so happens that's exactly where it comes from. 1/2, the perimeter would be all of the bases of all those triangles added up. The apothem is the height of one of those triangles. So just realize if we want to find the area of this regular hexagon, all I got to do is find 2 things, the apothem and the perimeter. Well, I'm hoping that you guys kind of already figured out what the perimeter was because each of the sides measures 10. 10 times 6 gives me a perimeter of 60. Now, the tricky part is how do I come up with that apothem? I'd like to give you a recommendation on how to do this every time. So what I want to do is I want to take one of these triangles. I'm going to pull it out of there just so I can kind of see what's going on. Here's the apothem. There's the radius. And there is the bottom, which, does everybody realize, is half of one of the sides there. What we really want to know is, what is that apothem? Well, we know one side of this triangle because we know all the sides measured 10. Cut that in half, we actually have 5 for the bottom of that triangle. Now here's where you need to be ready for an old skill, trigonometry. If I had 2 sides of the triangle, I could use Pythagorean theorem if I wanted. I'd like you to be prepared for trigonometry. Now in order to do trigonometry, better have an angle. The angle I can show you easily how to find is the one here inside, here up here where the center of the shape is. So this is a central angle. Does everybody understand that if we make one trip around this center point, that's going to be 360 degrees? Well, if I know this triangle has been replicated 12 times around in a circle, I can just take that 360 degrees and divide it into 12 pieces, which means I know that central angle, if it's a hexagon, is going to be 30 degrees. Now in a hexagon, if that's 30 degrees, that's 90 and that's 60. You could do a special right triangle problem if you wanted, but that doesn't always work. Trigonometry will always work. So let me show you just a quick refresher of trigonometry. We would want to label the sides. I don't have the hypotenuse. My opposite side, opposite the angle, is here where 5 is, and the adjacent side happens to be the apothem. It's not always A, so just be careful. So if I wanted to set up my trig problem, I'd want to know, okay, remember sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. I need to be doing a tangent problem. Equals opposite over adjacent, 5 over A. And since I'm missing one of my sides, I want to solve this like a proportion. Put it over 1 and cross multiply. 1 times 5 is 5. And then I have A times the tangent of 30. I want to get A by itself, so I need to divide the tangent of 30 to the other side. And now I can grab my trusty calculator. Remember, if you're doing trig, hit that mode button. Make sure you're on the degree setting, otherwise you will get this wrong. Now that I'm on the degree setting, I'm just going to plug in what I read. 5 divided by the tangent of 30, which means my apothem is about equal I'm going to take this out several steps, about 8.6603. I'm going to take it out a little bit to make it a little bit more precise because I'm not done with my problem. I need to take this apothem and plug it in here. Now I know I wrote it down as a rounded value, but you know what? I'm going to use this unrounded value here because if I just hit times, it's going to grab that entire answer unrounded, and then I'm just going to put the rest of this into my calculator. All right. I can put in 0.5 for 1/2 and multiply by 60. So I have the apothem times the perimeter, and I want 1/2. Which means the area, if I was rounding to the tens, 259.8. If I knew this was meters, remember we're doing in areas, so this is meters squared. This process will pretty much work every single time. So in case you want to see it one more time, let's take a look here. I'll give you a regular pentagon this time. Maybe this time, I know the apothem, but I don't know any of the sides. Let's say the apothem is 6. I want to find the area of a regular polygon. I'm going to use this formula. Good news is, out of 2 things that I need to find, I've already found one of them. The apothem is 6. Now, if I want to find the perimeter, I need one of the sides. The way I'm going to do that is I'm going to find the bottom of that right triangle. Trying to remember the key to finding missing information in these regular polygon problems is going to come down to a right triangle. I know the apothem. I really want to find this bottom side so I can find the missing perimeter. Well, remember, trig's the way to go if I can find the central angle. So you got to try and remember, how many of these triangles will there be in a pentagon? Well, there will be 2 for every side. Since there's 5 sides, there's going to be 10 of those triangles in there, which means I want to take the 360 degrees and divide it into 10 equal pieces, which means my central angle is going to be 36 degrees. And it's game time again. I still am using opposite and adjacent, which means I'm still doing a tangent problem. Tangent of the angle has to equal the opposite side over the adjacent side. Since I'm missing a side, we'll go at it like a proportion. 1 times x is x, and then I got 6 times the tangent of 36. Since I have x by itself, it is calculator party time. 6 times the tangent of 36. Now, careful, because that is only this piece, which is only 1/2 of one side. If I take that and I double it, I have 1 whole side. But remember, I want to find the perimeter. So if that's a whole side, and we have a pentagon, I'll multiply by 5 to get the rest of the sides. And again, I may write down a rounded value. Maybe I'm writing down 43.59 as my perimeter, but I'm not going to get rid of this unrounded value. I'll just take this times the apothem times 1/2 so that I haven't rounded yet. And my area, let's say these were maybe feet, my area would be 130.8 square feet. So try and remember, one formula, Works every time, as long as I know that it's a regular polygon. You got to know about that information. If it's a regular polygon, this will work. It's only two things to find, and it's always going to come down to a right triangle problem. If you can find your two missing pieces, you are home free to come up with a great answer. We will work several more problems in class. Please don't miss class. I really hope you're watching these videos before you come to class so that you can refine and practice. Not try and learn at class. Learn by watching this video. If it doesn't make sense, you're armed with questions and an inquisitive attitude when we come to class, and you're a bit familiar. You're not starting from scratch. It's very, very important to watch these videos. I'll see you in class.